everyone, we are from Physics 1 class period 3. Me, Rai, Nadine, Hiro, and Jack will be talking about kinetic molecular theory and thermodynamics law.
Boyle's law is a law that states a gas's pressure and volume are inversely proportional. If the molecules in one container goes down and the other one goes up, it is expressed in Boyle's law, which is stated as P1 V1 equals to P2 V2. On the other hand, Charles' law is a law that states a gas's volume and temperature are directly proportional. For example, if we have gas in a balloon and we heat it up, the particles will move more quickly in order to keep the pressure constant. Therefore, it comes to a formula of V1 over T1 equals to V2 over T2.
What is Kelvin scale? Kelvin scale is a temperature scale that has no negative values. Now, what is combined gas law? Combined gas law states that the ratio of the product of pressure and volume and the absolute temperature of gas is equal to a constant. It states that equal volume of gas at the same temperature and pressure contain the same number of molecules. Therefore, it creates a formula of P1 times V1 per N1 times T1 is equal to P2 times V2 per N2 times T2. And what is the example? If a balloon is filled with helium on the surface of the Earth, it will have a certain pressure, temperature, and volume. And if the balloon is let go, it will rise. Further up in the air, the temperature and air pressure begin to drop. Now let's further talk about what is ideal gas law. The ideal gas law states that under the same temperature, volume, pressure of gas contain the same number of molecules. Therefore, it creates a formula of P times V is equal to N times R times T, where P is the pressure in Pascal, V is the volume in meter cubic, N is the amount of substance, mole per cubic meter, R is the ideal gas constant, energy per temperature increment per mole, and T is the temperature in Kelvin. And how can the ideal gas law be applied in a real-life situation example? In a refrigerator, the coolant gas is compressed, which means that the volume of gas is decreased. That eventually increases the temperature. Now, what is Brownian motion? The Brownian motion states that particles in a fluid, liquid or gas, exhibit random motion collision with fast-moving molecules or atoms in the fluid. After knowing the kinetic theory of gases, what are the observable properties of gas? There are pressure in Pascal, temperature in Kelvin, mass in kilogram or gram, and also the volume where the gas is contained. Now let's jump into chapter 2 talking about the fourth thermodynamics law.
We have the zeroth law of thermodynamics. The zeroth law of thermodynamics takes into account that temperature is something worth measuring because it predicts whether heat will transfer between objects or not. The zeroth law of thermodynamics begins with a simple definition of thermodynamic equilibrium. If two of these objects are brought into physical contact, there is initially a change in the property of both objects. The temperature of system A will equal to the temperature of system C, and the temperature of system B will equal to the temperature of system C. An example would be that the zeroth law in action can be seen by taking a very common thermometer having mercury in a tube. As the temperature increases, this mercury expands since the area of the tube is constant.
For the first law, thermodynamic law outlines the relationship between internal energy, which is classified as U, work, which is classified as W, and heat, which is also classified as Q. The law can be stated as an equation which is delta U equals Q minus W. This means that the change of internal energy of a system will be equal to the energy transferred to or from the system as heat, minus the energy transferred to or from the system as work, and all of these quantities will be measured as joules. There are multiple processes scenarios that could occur, such as the first one, which is if a process occurs where there's no change in volume for the system, that means there is no pressure or volume work that can be done on or by the system. So work equals to 0. This is called an isovolumetric process, meaning no change in volume. And for the second one, if there's no change of temperature in the system, there won't be any change on the internal energy since these two values are proportional. This is called an isothermal, which equals to no change in temperature. If there is no heat transfer, Q will equal to 0 and delta U will equal to minus work. This means that the internal energy of a system changes as a result of doing work on its surroundings or the surroundings doing work upon the system. This process is called adiabatic process, which means no heat transfer. So for an example, 100 joules of work is done on a system. Internal energy increases by 74 joules. How much energy is transferred as heat? So let's take our equation to find Q, which is Q equals to delta U plus W. For delta U, we can input 74 joules because it's increasing, which means that it is positive, and negative 100 joules for work since work is being done on the system. And we should get Q equals to negative 26.
The second law of thermodynamics. In summary, the second law of thermodynamics is the disorder of the universe is always increasing. This disorder is called entropy. A system's surroundings will always have more disorder than a system itself. In real life, we can see the second law of thermodynamics in action as heat transfers from hot objects to cold objects because of the irreversible process of entropy. Entropy increases as temperature increases due to the kinetic random motion and disorder exhibited in hotter states of matter such as gases and liquids. A system's final and initial entropy can be the same, but a system's entropy is always less than its surroundings. The symbol for entropy is S, and when there's a change in entropy, it's delta S. The formula to find entropy is heat transfer divided by temperature. An example of entropy: a mug is room temperature in a cold room, and a hot liquid is poured on the inside of this mug. Over time, heat spreads from the liquid and into the mug. When placed on a surface such as a table, the heat then spreads from that mug to the table, and over time, the liquid in this mug becomes cooler and cooler as heat is transferred into the mug and then the table.
Lastly, let's move on to the third law of thermodynamics. The idea of the third law of thermodynamics is absolute zero, where the law states that the entropy of any crystalline substance at absolute zero will be equal to zero. Therefore, the law can be stated as S equal to zero. It predicts that the entropy, which is the measure of randomness or disorder in a system, of a pretty crystal would be zero when the temperature is at absolute zero. And at absolute zero, all substances would be in solid phase, and all particles would have no or have zero kinetic energy, and it is measured in Kelvin temperature scale. An example can be shown in refrigerator, as these appliances cool down the enclosed space by removing heat. They decrease the internal temperature by expelling the heat, yet no matter the efficiency or the length of operation time, they cannot attain an absolute zero temperature. And these are the sources that we use. Thank you for listening. Hope it is useful.